We have 3 different examples, so make sure you see all 3. And again, we're working on standard form, and we're specifically going to work on today finding the vertex, the axis of symmetry, and the y-intercept of this parabolic shape, of this quadratic function. And later down the road, we'll practice plugging in ordered pairs to get the entire shape, okay? But we're just gonna slowly start working on a few things. So I gave you some of the steps here, which are also listed above, to find all of the following. And this is really the order that I think is easiest to do it in. It kind of saves the most time. So first step, we're going to work on finding the y-intercept. So remember, if you want y and you don't want x, right, you're just plugging 0 in for x. That's y. You end up with 0, c, right? If I want y, I want y-intercept, and I don't want x, you just plug in 0 for x. And then when you simplify, 0 squared is 0, right? And 0 times 2 is 0, so that cancels. And 4 times 0 is 0, so you just end up with 3. So that's why we say 0, c, because 2 is a, positive 4 is b, and c is 3. So you can plug in, but you can save yourself a little time by just writing 0, comma, whatever the c value is. 0, comma, 3. Okay. Now notice on the graph below, I did a little screenshot for us. We see that on the y-axis, right, it's a y-intercept. So on the y-axis, we touch at 3. Now notice that this jumps from 2 to 4, so it's not like 2, 3, 4, 5, right? So it's scaled a certain way. But right in here, that's 3, okay? So this is our y-axis, so our y-intercept is at 0, 3. Okay, now let's work on finding our axis of symmetry. Now they give us a formula, it's negative b over 2a. Okay, on the bottom you're always going to have that 2. So you're plugging in a value for b and a value for a. You'll always have a negative in front. Just be careful when you're plugging values in, because sometimes you'll end up with double negatives. Okay, so for this problem, I'm going to down here write step 2. And I think it might be faster to do it this way. Oops. Maybe not. Okay, so for this problem, if I have x equals negative b over 2a, it's not really easier. Okay. So let me just go back to what I was doing. I thought it would be a little bit neater. Okay, so we have x equals negative b over 2, whatever a is. So if I look up here, if it's negative b in the b slot, b is positive 4, right? So I'm going to plug in positive 4 for the b. And if it's over 2 times a in the a slot, we have 2. So we end up with, I like to throw the negative on top in front of the b parentheses. So we have negative 4 over 2 times 2 is 4. And when we simplify, we get negative 1. Okay, so our axis of symmetry, right, that vertical line that slices our graph in half, goes through the x-coordinate of the vertex, is x equals negative 1. So this is a vertical line, right? So if you notice, right over here, we end up with our vertical line, and again, it's we're not counting by ones. Over here, we're actually counting by halves. So this is like negative half, negative 1. So it slices through. And then if we look at the next part, step 3, the x coordinate of the vertex is the same value as the axis of symmetry. So it's actually also going to be negative b over 2a, which we already have that value, right? So in step 3, we already know the x coordinate of our vertex. It's the same as our axis of symmetry value. We know it's negative 1. So then, remember to find the y coordinate, the next step. To find the y coordinate, we're going to plug the x value from step 3, right? So the x value from step 3, the x value is negative 1, into our original equation for x and solve for y. So we're going to say f of negative 1, right? This is telling someone what we're going to plug in for x, which we know ultimately it's y equals. So we're going to do 2 parenthesis squared plus 4 parenthesis plus 3. And again, we're saying we're going to plug negative 1 in because we have negative 1 as the x coordinate, and we want to see what the y coordinate is when we plug in negative 1 in for the x value. So remember, you have to do order of operations. So first step, we're going to do exponent first. Since negative 1 is in parentheses, negative 1 times negative 1 is positive 1. So we get 1. You gotta be careful, and you gotta do order of operations. Next, if I do positive 4 times negative 1, notice I'm circling this sign. Positive 4 times negative 1 is going to be negative 4 plus 3. If I multiply 2 times 1, I get 2. Order of operation, PEMDAS, let's move from left to right. So 2 minus 4 is going to get us negative 2, and negative 2 plus 3 is going to get us 1. So we know now we're going to put that up here. When we plug in negative 1 into our equation, we get out 1. So the ordered pair is negative 1, comma 1. That is our vertex. So if we look at this graph, I put the equation already in actually to Desmos to see the picture, which if you guys want to go to Desmos, you can plug these in to see if it looks accurate. So again, if we were counting on the x-axis, if the scale was negative halves and it's negative 1, 1, and on the y we're also counting the same, we would have negative 1, so negative half, negative 1, did I do something wrong? Negative 4 over 2 times a is equal to negative 1. So then we have negative 1, 1 would be here. Did I put the wrong picture in? No. Oh, I was just checking myself for a sec, because I cut off the x-axis. Okay, so negative 1, 1 is right in here, so that's our vertex. Okay, so our axis of symmetry, the line that goes through our vertex, is x equals negative 1. Our vertex is the ordered pair, negative 1, comma positive 1. This was the x-axis down here, if you looked on Desmos. And then we've done everything. So again, we have our y-intercept is 0, c, or 0, 3. And we know that because if we're counting by halves, right, this is 2.5, and then half more is 3. So 0, 3, our y-intercept is 3. Our axis of symmetry, negative b over 2a. When we plug in b and a, we get negative 1, so it's a vertical line. X equals negative 1. Again, if we're counting by halves, this is negative a half, negative 1, so that's why we drew it here. And then our vertex is negative 1, 1. We plug in the x coordinate of our axis of symmetry, or you can find it negative b over 2a. Once we get that number, we plugged it into our equation in the x slot, and we get out 1. So we know that our vertex, we plot negative half, negative 1, comma, up half, up 1. So that's the spot negative 1, 1 due to the scale. Okay, I'm going to stop here, and then I'm going to do another video for example 2, and then another example for another video, for example 3.